warm welcome. Today we are going to talk about a very important topic, which is called the acid and bases. The objective of this talk is to define what is an acid and what is a base. We'll have to define the properties. My name is Dr. Anush Sharma, and so let us get to these concepts right now. So the common scenario we always face is that what happens if we bite a lemon, someone bites a lemon, just like this person is biting a lemon or this woman is biting a lemon. So what is the feeling? So unfortunately we get a very stinging or sour in taste feeling, a very stinging sour feeling. We always experience this sort of feeling. Now imagine what happens if someone accidentally bites a soap. Hope it doesn't happen, but what will be the feeling? As this person is making out, it's very bitter in taste. So the question is, why a lemon and a soap taste sour and bitter respectively? That's a big question. Because both the lemon and soap, because they have acid and base substances in them. So that brings us to the biggest discussion: what are acids and bases? So let's go deep into these concepts. So what is the definition of acids? Now the term acid is derived from the Greek word named acidus, which is meaning sour. However, the scientific community has found it very difficult to define what really is acid and base. Over the last quarter century, only two theories has really evolved to explain this phenomenon. Number one is the Arrhenius theory. Now what is the Arrhenius theory? This was a famous Swedish physician named Svante Arrhenius in 1884. Remember 1884, he defined acids as substances which when reacts with water, it gave rise to hydrogen ion. So remember, one is very important: the hydrogen ion is an acid. It gives to hydrogen ion. As you see from this example, the hydrochloric acid, when it's given into water, it forms hydronium ion and a chloride ion. And similarly, he defined bases as substances which when reacts with water, it gave rise to hydroxyl ion. So acid gave rise to hydronium ion, bases gave rise to hydroxyl ion. As you find, sodium hydroxide is a base. When it is put in water, now what are the common Arrhenius acids? Hydrochloric acid, nitric acid, sulfuric acid. What are common bases, Arrhenius bases? The sodium hydroxide, potassium hydroxide, calcium hydroxide, and magnesium hydroxide. However, there are certain demerits about this Arrhenius theory. Now what Arrhenius said was, acids are substances which have to react with water. So also bases are substances which have to react with water. And acids produce hydrogen ion and bases produce hydroxyl ion. Now what is the catch? There are certain substances which may act as an acid without reacting with water. The second point is that there are some substances which may not yield hydroxyl ions, but they still act as a base. So because of these demerits of this Arrhenius theory, the second theory which has come out in 1920 given by Bronsted and Lowry, which is the Bronsted-Lowry theory, which states that acids are substances which donates the hydrogen ion and bases are substances which accepts the hydrogen ion. Now this theory makes a little sense. How it really makes sense? So we go to a very important theory. Now see, hydrochloric acid, when it reacts with water, it gives rise to hydronium ion and a chloride. Now look very closely. Hydrochloric acid is an acid because it has donated a hydrogen ion to the water and it has formed hydronium ion. So this is an acid. Water acts as a base. This is called the Bronsted base, Bronsted-Lowry base. Hydrochloric is an acid. Now because water has achieved one hydrogen ion from the hydrochloric acid, so this is called the conjugate acid. Conjugate acid of hydrochloric acid is hydronium ion. Now look what happens to chloride. Chloride has lost its hydrogen ion, so now it acts as a base. So as we see from the Bronsted-Lowry theory, that it may not have to yield hydroxyl ion as stated by Arrhenius to say that this is a base. Chloride acts as a base. So let us look at another theory. The ammonia, NH3, when it reacts with hydrochloric acid, it forms ammonium. Now look very closely in this equation. The ammonia has got one hydrogen ion from the hydrochloric acid. It has now put ammonia. So this acts as a ammonia acts as a base. But look very closely here. What is the reactor? It is reacted with hydrochloric acid. It has not reacted with water. So according to Arrhenius theory, to say it is a base, one must react with water. But hydrochloric acid is not water. Number one. Number two is that we find that no hydroxyl ion is been formed. So, but still the chloride acts as a base. We didn't have. So the next third theory that has been found out is the 1922 Lewis theory. Now Lewis theory is very difficult to explain. Now it says that acids are substances which accepts an electron pair. In an atom we find that there is a hydrogen electron pair, and bases are substance which donates an electron pair. It is a very difficult concept to understand, but the biggest theories are based this. So we find that the Arrhenius theory has said that yielded hydroxyl ion, hydrogen ion, whereas bases yield hydroxyl ions. Lowry's theory says that acids are substances which are hydrogen donors, and bases are substances which are hydrogen acceptors. And Lewis theory says that acids are substances which accepts electron pair, and bases are substances which donates electron pair. Now let us go to the properties of acids and bases. Now acids, they characterize by 4 properties. Number 1, it is very sour in taste. Very sour in taste, as this person is experiencing. We common take so much sour acid things in our day-to-day life, like lemon, grapes, vinegar. These are very sour in taste. Then secondly, very highly corrosive. It can burn body surface. So if accidentally hydrochloric acid or sulfuric acid comes in contact with body surface, it burns the surface because of the presence of the hydrogen ion. And also the sulfate of acid is the most important, is that it changes the color of indicator. That means it changes the color of blue litmus paper to red. As you see from this, there is a blue litmus paper and it has changed to red on coming in contact with the acid solution. Is that now it can conduct electricity. Now how it happens? Because the acid, when it reacts with water, it produces hydrogen ion and an ion. So these positive and negative charges moves freely in water and they can conduct electricity. Secondly, what are the properties of bases? Now bitter in taste, very bitter in taste, and becomes foamy and slippery once they come in contact with water. They're very bitter in taste and becomes very foamy and slippery. So for example, we always experience examples the soap. We see soap when it comes with water, it becomes very soapy as foamy. And other examples of bases we always see in the day-to-day life: baking soda, washing soda. Then secondly important thing is what is the red litmus to blue. So this is an important fact. I see from this slide we find that the acid from the blue litmus it has turned to red, and from the base to blue. Then what are the other properties of base? It neutralizes the action of acid. So how it neutralizes, this is a very important factor. For example, hydrochloric acid is present in the stomach. When it reacts with base, sodium hydroxide, it produces salt and water. So it neutralizes the action of base. Secondly, as in acids also, bases also can conduct electricity, because look at sodium hydroxide. When it combines with water, it produces sodium positive ion, hydroxyl negative ion. So this positive and negative, they move freely in water and they can conduct electricity. So another important test to distinguish an acid and base is the phenolphthalein and methyl orange test. We say in phenolphthalein what will happen is that it remains colorless. When you put few drops of phenolphthalein acidic medium, it remains colorless, while in bases it gives a pink color. Similarly, what happens in methyl orange, when you give few amounts of methyl orange, it changes to yellow in case of base, and in case of acid it turns to red. So in short, what we found is that, in summary, what are characteristics? Acid tastes sour, bases taste bitter, it is highly corrosive. In the litmus test we find acid turns to red, blue litmus to red, bases turns to blue, methyl orange in acidic medium turns to red, and base turns to yellow. Phenolphthalein, most important, there is no color change, and in base there is a pink color change, and electricity, both conducts electricity. So thank you for watching this channel. I hope we will present further cases in the subsequent lecture. Please subscribe to my channel. Till then, take care. Thank you.